Hello everyone, welcome to Study Guide Forum. Today we'll be looking at some of the features of a periodic table. Now, periodic table, like we've already stated, is formulated by a Russian scientist known as Mendeleev in 1869. Now, based on the modern periodic law, we're able to know that the an element um, properties of an element that the both physical and chemical properties of an element is of what periodic function of their atomic number. Now, when we look at these things based on that, we're going to be looking at some relationship that exists in the group. In each of the groups, we find out there is always relationship that exists there. In each of the groups, you find out that they are similar in their reactions. Now, in this group, there are four groups that show a very high level of similarities in their reaction. That is the group one, group two, group seven, and what the noble gas. That's zero, the group zero. These four groups show a lot of similarities, and the group one is called what alkali metal, while the group two has a family name of we call what alkali earth metal, while the group seven is the one we call what the halogens, while this other one the zero or the eighth group here, which is called the noble gases. Their reaction seems to be each of these groups show a high level of similarities in their what variation. Now, this variation in each of the group is what we call the group trend. We call it what the group trend. The group trend is very obvious. Now, when we move down from there, when we move down to the periods, when you move to the period, you find out that there is a continuous variation in properties. As the atomic number is increasing, there is always changes in their chemical and physical properties. Now, from one group, for example, let's start from this group, from this period three. In this period three, we're talking about the vertical horizontal column now, which is the period. Now, from here, the metallic property is decreasing from this point to the other end. Metallic property is what increasing, it's decreasing from what group one down to group three. Group four, we have the one we call the metalloids. From the metalloids, we move down to the one we call the non-metals. Group seven tends to be the most reactive non-metals, while group zero tend to be the inactive. They don't react effectively. They don't even undergo any reaction. This is because of the problem of their what completely filled electrons in the outermost shell. Now, another thing we should also note here about the another thing we should note about the um, the period. In each of the periods, like we already said before, they have the same number of shares, the same number of shares. We have already said that thing before. So another thing we're going to be looking at. So the next thing we look at here, um, you find out that is always a decreasing metallic property decreases across the period, and that means from the right now to left, metallic property is what increasing. I said from right to what left, metallic property is increasing, while from left to right, metallic property is what decreasing. Now, there's another thing we should also note in this case. We have what we call diagonal relationship. Diagonal relationship. Diagonal relationship. This as a result of that as we go down each of the groups, we find out there's a decrease in property. For example, this other one, group one. In group one, there is increase in properties. That means there's a variation in each of the group. Down the group, there's always a variation that a constant trend of variation that exists down each of the group. For the metallic properties, we notice that down each of the group, we notice that for the metals, there's always an increase. Sodium from lithium down here, we have an increase in metallic properties and reactivity. Now, the diagonal relationship is simply what happens diagonally. Lithium and magnesium tends to have similar properties because of change in the variation in the properties as you move down the group. Now we'll come to this other one. Beryllium and aluminium tends to have similar properties. The same thing goes with boron and what silicon. So all these things is example of what diagonal relationship that we have here. So the next thing we'll be talking about when we come back again will be some of the we talk about the ionizing energy. We talk about ionizing energy and all the rest of them. Talk about atomic radius and all the rest of them. We know how it relates to what really happened in this case. And other ones we should be looking at. And then we'll go into detail because I really did not really talk about the the effects, this effect of the electron uh, electron charge, the nuclear charge, the force of attraction of the nucleus that tends to draw all electrons to itself, and the screening effects that normally happen. What happens when two um, positive um, positive electrons, when electrons are together because of the similar charge, they tend to repel each other. Yes, when two electrons they are together because of similar charge, they tend to repel each other. This what results to what we call the screening effect. We're going to be looking at it in full details. Thank you for being part of this class, and don't miss our class. If you are coming for the first time, if you are joining us for the first time, we want to encourage you to subscribe to our channel. There's a lot so that you will join us in the fun we're having every day. Thank you so much.